Hi, welcome to Crosslight tutorial. Today I'm going to show you how to define cut lengths on this racetrack structure. Crosslight uses cut planes for C-Supreme 3D simulation. This means the structure will be cut into several planes in Z direction. For example, in a thin-fight structure, several cut lengths should be defined for a 3D simulation. The structure will be cut into several 2D mesh planes with respect to these cut lengths. Let's look at these planes without connection. This method will greatly reduce the mesh required for 3D simulation and improve simulation speed. When it comes to this structure, we use the same method for 3D simulation, but we cannot just simply define cut lengths in Z direction. We need to define cut lengths along the racetrack. So we developed a new method, mixed cylindrical cut, to define cut lengths for this kind of structure. Okay, I will introduce how to define cut lengths by mixed cylindrical cut. There are two methods here. The first one is straight cut. For example, there is a polygon. We call it a block. How to define these cut lengths on this block? You can imagine this block as a racetrack. This is the starting line and this is the finishing line. The distance between the starting line and the finishing line is total distance. If you work on the track, this is your left-hand side, this is your right-hand side. At first, we should define initial reference point and initial cut angle. Usually, we can take the starting point or left boundary as the initial reference point. In this case, I will take the origin or the coordinate as the initial reference point. The parameter start left xy is used to define initial reference point. Initial cut angle is the angle between the starting line and x-axis. In this case, the starting line and x-axis are coincident, so initial cut angle is 0. In this mixed cylindrical method, the reference point and the reference angle is not fixed. If you go straight forward in this direction, the reference point will move in the same direction. For example, if you move from the starting line to here, the reference point will move from the initial reference point to here. When you walk along the track, the distance between the left boundary and the reference point is defined at the left side. The distance between the right boundary and the reference point is defined at the right side. Now let's define the left boundary and the right boundary of this block. These are the starting point. These are the finishing point. For the left boundary, the left side of the starting point is 2 micron. The left side of the finishing point is 2 micron. So the left boundary can be defined as left side from is 2, left side to is 2. For the right boundary, the right side of the starting point is 3 micron. The right side of the finishing point is 6 micron. So the right boundary can be defined as right side from is 3, right side to is 6. How to define a cut line on this block? If the distance between the cut line and the starting line is given, this cut line will be defined on this block. Cut distance is the distance between this cut line and the starting line. If you want to define several equidistant cut lines on this block, you should use cut distance number. If cut distance number is 5, 5 equidistant cut lines will be defined, including the starting and the finishing cut lines. The second method is cylindrical cut. For example, there is a circular block. We need to define some cut lines like this on this block. You can imagine this block as a racetrack and move on the track in counterclockwise direction. The inner circle is your left-hand side, the outer circle is your right-hand side. The angle between the starting line and the finishing line is total angle. At first, we should define initial reference point and initial cut angle. In this case, I will take the origin of the coordinate as the initial reference point, and the angle between the starting line and x-axis as the initial cut angle. In cylindrical cut, except for the initial reference point and initial cut angle, the center of the circle should also be defined. Shift origin is used to define the distance between the center and the initial reference point. If shift origin is positive, the center is on the right side of the reference point. If shift origin is negative, the center is on the left side of the reference point. In this case, the center of the circle and the initial reference point are coincident, so shift origin is 0. As is said in straight cut, the reference point will change when we move along the track. But the reference angle will not change because it keeps moving in the same direction. But in cylindrical cut, when you move in counterclockwise direction, the reference point didn't change while the reference angle keeps changing. The distance between the left boundary and the reference point is defined at the left side. The distance between the right boundary and the reference point is defined at the right side. Now let's define the left boundary and the right boundary of this block. These are the starting points. These are the finishing points. For the left boundary, the left side of the starting point is 4 micron. The left side of the finishing point is 4 micron. For the right boundary, the right side of the starting point is 6 micron. The right side of the finishing point is 6 micron. So the left boundary can be defined as left side from is 4, left side to is 4. The right boundary can be defined as right side from is 6, right side to is 6. Now let me show you how to define a cut line on this block. If the angle between this cut line and the starting line is given, this cut line will be defined. Cut angle is the angle between this cut line and the starting line. Cut angle number is used to define equi-angle cut lines on this block. At last, let's do a conclusion of the mixed cylindrical cut. When define cut lines for a structure, the structure may have several blocks. When you move on the track, the reference point and the reference angle will change. But the initial reference point and initial cut angle are unique. I mean, start left xy and initial cut angle should be unique for a structure. So we should define start left xy and initial cut angle before define cut lines for the first block. We usually take the starting point of the left boundary as the start left xy. Cut initial angle is the angle between starting line and the x-axis. Working on the track, every time we make a turn, a new block should be defined. Now let's go back to the example. I will show you how to define cut lines on this structure by mixed cylindrical cut. To be clear, only counterclockwise is supported in cylindrical cut so far. I mean, the starting line should be this line instead of this line. To define cut lines, we should define initial reference point and initial cut angle at first. I will take the starting point of the left side as start left xy. It's 249 and 0. The unit is micron. The angle of starting line and x-axis is initial initial cut angle is 90 degrees here. If you start from the starting line and working along the track, you will make a turn at this point. So this is the first block. Let's define cut lines for the first block. I will use straight cut. Total distance is the distance between the starting line and the finishing line of the block. It's 249 microns. Because the reference point is on the left boundary, so left side from is 0, left side to is 0. Right side from is the distance between this point and this point. It's 615 microns. Right side to is the distance between this point and this point. It's 650 microns. I will define 4 cut lines on this block, with cut distance equals 50 microns, 100 microns, 150 microns, and 200 microns. We've defined 4 cut lines, but there are actually 6 cut lines on this block. That's because the cut lines on the starting line and the finishing line are default. Keep moving on the track. When you arrive here, you will make a turn. So this is the second block. Let's define cut lines for the second block. For the second block, I will use cylindrical cut. Total angle is the angle between this line and this line. It's 90 degrees here. Shape origin is the distance between the center and the initial reference point. In this case, the reference point and the center of the circle are coincident, so shape origin is 0. Left side from is 0, left side to is 0. Right side from is 615, right side to is 615. I will define 2 cut lines with cut angle equals 30 degrees and 60 degrees. This is the 30-degree cut line. This is the 60-degree cut line. The cut lines on the starting line and the finishing line are default. For the last block, we use straight cut to define cut lines. Total distance is 249 microns. Left side from is 0, left side to is 0. Right side from is 615. Right side to is 615. Its cut distance number is 6. 6 cut lines will be generated on this block, including the starting line and the finishing line. So we have finished definition of cut lines for this structure. This is the structure we get after 3D simulation in C Supreme. These are the cut lines we get with mixed cylindrical method. This is the net doping distribution. I just skipped the process flow here. Please refer to other Crosslight tutorials for more detail. Thank you for your attention.